Okay, so this one is a greater than, and again, I'm going to reference these notes that are going to come with the exam, because if you get what's going on here, you pretty much are going to get these right, other than, the little silly errors where you make arithmetic stuff. But this is your setups, and this is absolutely what you want to look at. So if this said equals, I'd be doing this first thing, because that's our plan for an equation, is I get it simplified to here, and then a equals b, or a equals negative b. If it's a less than, that's the kind where it sets up in between, which is I think what you did based on the answer. And then if it's a greater than, it's the kind where you set up the two separate ones, and you're going to get the graph with the heading out to infinity with the gap in the middle. And for a less than, it's going to be, let me write this over here. For a less than, it's going to be this kind of graph where the graph is in between. And for greater than, it's going to be this kind of graph where the graph is going out to the edges. And that's every time. And so if it's a greater than and you're getting a closed set, it's wrong, because all greater thans are going to do this. So what you want to do is, and any of these absolute values, this is always your first steps, is to get that absolute value by itself. So let's bring the 9 over and get this thing divided out in a second. Let's see, 9z plus 4. That's gone, so that's going to make greater than or equal to 81. And then let's get that 9 divided. And cancel that and that. And so now we have absolute value of 9z plus 4 is greater than or equal to 9. Okay, so now we've simplified this as much as we can, and we have something of that form. So when that's the case, actually, let me do this for a second. Make that bigger, a little bit easier to see. Okay, so when this is the case, we set either the stuff inside is going to be less than the negative, so let's write that out. So 9z plus 4 is less than or equal to negative 9, or the stuff inside is going to be greater than or equal to the positive. So 9z plus 4 is greater than or equal to positive 9. Again, just don't get creative here. If it's a greater than, boom, that's it. If it's a less than, it's going to be that every single time. And then we'll solve it out. The only sneaky ones which I wouldn't put on the test is if there's a negative out here, and those are the all real number or no solution type. But in terms of exam questions, it'll be something that has an answer like this one. And then we just solve each of these. So we'll add that 4 over. So 9z, subtract the 4 over. So minus 4 is going to make minus 13 there. Divide the 9. And we get z is less than or equal to negative 13 ninths. And on this side, I will subtract that 4 over and get 9z is greater than or equal to, that'd be 5. And then dividing z is greater than or equal to 5 ninths. So in interval notation, z is less than or equal to negative 13 ninths. Again, you don't have to draw the graph, but it can kind of help just for seeing how the interval notation sets up. So this would be negative 13 ninths, and z is less than that. So that's going that way. And z is greater than or equal to 5 ninths. So that would be going that way. And again, you don't have to write any of that, but if it's helpful to see, then you're going from negative infinity up to negative 13 ninths. And then that's solid, so I would use a bracket, and then union from 5 ninths up to infinity. But so every greater than should have that union in those two branches. And then again, if I flip this around and it was the other way, it would be this one, and it would just be from negative 13 ninths to 5 ninths, and that's this one right here. So your first step on any of these is, is it an equals, or is it a less than, or is it a greater than, so that you get going down the right road. And then from there, always isolate that absolute value, and then don't be creative. Like, this is all figured out, so just do what the plan is for each of those styles. Hopefully that helps.